Hello, everybody. Let's learn about vectors. So, vectors are variables that have direction associated with them, and we've already seen a few of these vectors in our course. We've learned about position, displacement, and velocity, and we're going to learn about acceleration and force next. What makes a vector is that it has both a size and a magnitude, or sorry, a size and a direction, right? So the word magnitude and size are the same. It means how big the vector is. So for example, we could say the velocity of a car is 13 centimeters per second and then east. So here we have both magnitude or size, if you rather, and direction. Variables or measurements which do not have direction associated with them are scalars. The magnitude part of a vector is a scalar. So we just saw this velocity vector. How fast does this car travel? 13 centimeters per second. If I don't say east, then I have specified the scalar part of that vector, the magnitude. Some examples of scalars are energy, time, mass. You might say time has a direction in that it seems to move forward, and perhaps we could imagine it moving backwards in some sort of science fiction scenario. But it doesn't have a direction like east or north or up, down, or left. We can't say 5 seconds north, for instance. So here, when we say direction is important, we mean spatial direction. So time is a scalar. Okay, we are going to be representing vectors on diagrams with arrows. The length of the arrow indicates the magnitude or size. So we will make our vector, the length of our arrows that we draw, proportional to how big the vector they are. Okay. Let's take a look at this example. We're going to draw some position vectors. It says that position vectors extend from the origin of the coordinate axes to the reference points on the object. So let's try that. Let's do C and D first, and then we'll do the other ones. So what is the position of car A? Where is it in relationship to the origin? And perhaps you could see that this is the position of car A. Notice that XA equals 2 meters west or negative 2 meters east. Both are acceptable. You might wonder, what is this funny symbol that I drew over the X? That's a way of writing down the symbol for a vector and specifying that that quantity is a vector. Okay, so when you're writing vectors by hand, pen or pencil, you can add that little arrow above the variable x in this case. What about the position of car B? X of B or x sub B equals, where's B? Here it is. There is XB. You could see that it is 7 meters east, or negative 7 meters west, if you prefer. Okay, now we skipped A and B, so let's do that. What is the distance of car A from B? And you could see the distance. Distance is a scalar only, okay? So distance scalar. And you could see that these cars are 9 meters. And it doesn't matter which way you go, from car A to car B or car B to car A, you must travel 9 meters in distance. Okay? There's no direction associated with scalars. But if we say, what is the displacement of car A, measured from car B. That means if we were to travel from car B to car A, we would have to start here and travel this direction. And you could see that the displacement is 9 meters west. Okay, 9 meters west. Whoops. Okay. Or negative 9 meters east. And similarly, what is the displacement of car B measured from car A? It's the opposite. It's 9 meters east. If we were to travel from B to A, we must travel 9 meters east. Displacement represents change in position. Okay, so once again, if you want to travel from car A to car B, here's A, here's car B, you must travel in this direction, 9 meters, okay? And more on this displacement thing in the next lesson on vectors. There's the change in position.